Hi, you're back with Lucas, and this video's topic is power systems. We're going to go into what they are and why we need to be able to control them, and how they relate to advanced manufacturing systems.
Every manufacturing process requires power. It's important to know the specific power requirements for the process we want. Often we are converting from one form of power to another, and it's important to understand how to work with these safely. Power systems, if they experience an uncontrolled or unexpected release, are quite dangerous. The first power system we'll be looking at is hydraulics. This is a slow and steady process that can give us strong outputs relative to the size of the system we're working with. Hydraulics is the system that uses fluid to transfer power. A pressure and volume in will equal a pressure and volume out. Usually the fluid we're working with requires some sort of reservoir, and then a pump to provide that pressure. Because of this, we need to understand how the flow of fluid works within our system, if there's any filtration that we need to do, and how to maintain our components so that they provide the adequate amount of power for the system that we're using. The next process would be pneumatics. This process requires an air system. They're noted for their ability to provide a quick response to an output. They're considered spongy because the gases don't necessarily follow Pascal's law and can be slightly compressible. This is both an advantage or disadvantage, as if we receive too much of a pushback on our load, we won't actually be exerting the power, it will be compressing our gas backwards. But it also can work to our advantage because this requires less space in order for our system to be adequately powered. Pneumatic systems require a receptor, a compressor, and some sort of transfer system, similar to what we would have within our hydraulic system. We can also work with a negative pressure, called a vacuum, which allows us to also do work within a system. Our third and final system is electrical. This can be broken down, obviously, within two types of electrical current: direct current and alternating current. Direct current is most commonly used within the control process, but can also be used for power. Many systems require a DC motor in order to operate effectively. On the reverse, AC power is more widely used than almost any other power system. But AC systems are hard to store their energy, so often we will convert from an AC power input to one of the other types of power in order to use our final process. It's important to understand how each system is wired up and needs to be used. When considering any power system, we need to think about the inertia that is going into it. An object in motion will remain in motion, but many of the processes we are using our power system on will change. We may be experiencing a change in load or torque of the system that we're working with, thus causing a change in the power requirements. This means that we may experience an uncontrolled release when we suddenly have a drop in the load or a sudden increase in the load, causing our system to break down and push back into our initial power systems. Lastly, we need to ask what type of power we need. Are we looking for speed, or are we looking for torque? Does it need to be fast? And how much space are we able to work in? And can we have a secondary power system? One power system that is slower but stronger, and a second one to give us the additional boost of energy that we need in those rare circumstances where there's an additional load upon our system. We also need to look at startup versus steady state. Particularly within AC systems, we may experience a high degree of pushback within the initial startup, a resistance to our current. But at the steady state, we need far less current in order to keep the system going. Power systems are a complex system that Mechatronics has allowed its students to understand and better appreciate.